Imagine watching a taximeter just spinning completely out of control.
Oh, that's a terrifying thought.
Right. But instead of a ride, it's your AI coding assistant. It's just quietly draining your entire monthly API budget.
Because Anthropic just put developers on a very tight ticking clock.
Exactly. The July 12th deadline is causing some serious widespread anxiety right now. They unexpectedly extended free access to Claude Fable 5 recently.
Yeah, but that generous extension is closing very, very quickly. Soon, those heavy usage credits are going to start draining your wallet.
It creates a really fascinating tension for developers everywhere. Welcome to our latest deep dive into the AI ecosystem.
Our mission today is highly specific and, honestly, incredibly practical.
We're exploring Anthropic's official technical blueprints for their AI models. We really want to help you use Claude Fable 5 efficiently.
Because you could actually get peak AI reasoning on a strict budget. You just have to be smart about it.
We're going to break down exactly why Fable 5 gets so expensive fast. We'll examine the underlying mechanics of large language model computation.
And then we'll explore two specific frameworks for reducing those costs.
Right. We're looking at the advisor pattern and the orchestrator pattern.
These two patterns are absolute game changers for developer workflows. They completely rethink how we allocate artificial intelligence resources.
It isn't just about cutting corners to save a few bucks. It's a mathematically beautiful approach to deploying different cognitive engines.
You're basically building a corporate hierarchy with different AI models.
Let's start by unpacking the core problem developers are facing. To fix a broken workflow, we first have to deeply understand it.
Right.
Why does Fable 5 burn through usage credits so quickly?
It really comes down to the balance of capability versus cost. Anthropic moved Fable 5 over to usage credits quite recently.
And then they extended the free access to July 12th.
Yeah, and it happened at the very last minute, surprising everyone.
It feels a bit like a FOMO marketing campaign, honestly.
It definitely leverages that inherent fear of missing out. People are rushing to use it before it costs them.
But Fable 5 is undeniably their most capable reasoning model.
Naturally, it's also the most computationally expensive one to run. Every single token it generates requires massive processing power behind the scenes.
Beat. We should probably define what makes a task computationally heavy.
Yeah, that's a good point.
Capability isn't just about knowing facts. It's about traversing probabilities. When an AI solves a complex logic puzzle, it works harder.
Right. It evaluates thousands of potential paths
before generating a single word.
That's a great way to visualize the underlying computing architecture. Letting Fable 5 handle a long, routine coding session is overkill.
Multi-step research workflows also consume these credits insanely fast.
You're basically hiring a brilliant neurosurgeon to put on a Band-Aid.
That's a perfect analogy. Most daily software work just doesn't require profound, deep reasoning.
No, we're usually talking about very standard, routine execution tasks here.
Like reading text files. That is a perfectly routine task.
Right. And writing boilerplate code is a highly repetitive, predictable software chore.
Formatting messy data and running simple tests are basic requirements. Claude Sonnet 5 handles these specific tasks absolutely flawlessly today.
It really does. It just doesn't need the massive neural network that Fable possesses.
2-sec silence. I need to be completely honest with you here. I still wrestle with my own laziness on this exact issue.
Oh, really?
Yeah, I often just default to the most expensive model available. I do this primarily to avoid writing better, more specific prompts.
Just throwing compute at the problem.
Exactly. I end up wasting my own API credits constantly because of it.
You're definitely not alone in that particular workflow habit. It's a very comfortable trap for busy developers to fall into.
When you're tired, throwing the smartest model at a problem feels safer.
But we really need to break that highly expensive habit.
It's financially unsustainable long term. Sonnet 5 is perfectly capable of handling the daily grunt work.
We just need to learn to trust the smaller, cheaper models.
But that introduces a very valid fear about the final output.
Yeah.
If we downgrade to Sonnet for these routine execution tasks, aren't we sacrificing the overall quality of the final product?
Not at all, and that's the brilliance of these new frameworks. The overall quality remains incredibly high across the entire project. That's because the heavy lifting is still reserved exclusively for Fable.
So Sonnet handles the grunt work, saving Fable for heavy lifting.
That's the core philosophy driving this entire optimization strategy.
Okay, we know Sonnet should handle the routine execution work now, but how do we know when to tag in the heavyweight?
Let's look closely at the first recommended pattern from Anthropic. This brings us directly to the Advisor Framework blueprint.
It's a highly efficient setup for linear, straightforward software tasks. Let's pause and unpack the actual mechanics of this framework.
Sure.
How do these two separate models interact with each other?
Well, Claude Sonnet 5 is tasked with doing all the routine execution. It reads the requirements, writes the code, and checks the files.
Just cruising along.
Exactly, completing the basic chores without any issues. But sometimes it hits a massive, complicated roadblock in the code.
A roadblock that requires deep, complex architectural reasoning to solve.
Precisely. It could be a very difficult, deeply nested logic bug. Or maybe it's a tricky, high-level system architecture choice.
When that specific roadblock happens, it actively calls Fable 5.
Right. It uses something internally called the advisor tool to connect.
Let's clarify that specific technical term for a moment. It's a built-in feature letting one AI ask another for help.
That's a perfect, concise definition of how the tool functions.
So Fable 5 then briefly steps into the active reasoning process.
Yeah, it reviews the deep context that Sonnet has already built up. It analyzes the specific problem and provides high-level strategic guidance.
Then it hands the reins right back over to Sonnet.
Right, and Sonnet just continues the standard execution phase immediately. Fable 5 doesn't greedily take over the rest of the session.
It steps in, drops some profound wisdom, and steps back out.
Exactly.
Beat. That's a really fascinating division of cognitive labor. I like to think about this dynamic in standard human terms. It's a lot like a junior developer writing the actual code. They're making great progress on their own at their desk. But they suddenly get stuck on a tricky structural database issue. So they walk right into the senior architect's corner office.
I love this analogy.
The architect looks over the technical blueprints very quickly. They point out the fundamental flaw and suggest a specific fix.
Right.
Then the junior developer goes back to their desk to type.
That maps perfectly to the underlying technical reality here. The senior architect is incredibly expensive to keep on the payroll.
You don't want them typing out basic HTML formatting tags?
No, you don't. And we actually have hard empirical data backing this strategy up. Anthropic recently ran the SWE-bench Pro benchmark on this setup.
Before we get to the results, let's explain that benchmark.
Sure.
SWE-bench Pro isn't just a simple multiple-choice trivia test. It evaluates an AI's ability to solve real-world GitHub issues.
It's a grueling test of actual software engineering competence.
What did the benchmark results reveal about this specific partnership?
This specific Sonnet and Fable advisor setup is incredibly powerful. It achieves about 92% of Fable 5's solo performance score.
Wow.
Yeah, it nearly matches the smartest model working entirely on its own. But it operates at only 63% of the total cost.
2-sec silence. That is a massive paradigm shift for developers.
It really is.
You retain almost all of the top-tier performance quality, but you slash the operational computing cost by over a third.
It's a massive efficiency gain for anyone building complex software.
Yeah.
It proves you don't need a sledgehammer to drive a small nail.
But my intuition says adding a middleman introduces friction.
What do you mean?
Well, how does Sonnet 5 even know it's genuinely stuck? Does it somehow self-diagnose its own cognitive limitations during execution?
It doesn't rely on self-awareness or spontaneous self-diagnosis at all. The prompt parameters explicitly tell Sonnet which decisions require a consultation.
So the prompt explicitly tells Sonnet when it requires a consultation.
That's exactly how the prompt engineering works under the hood. You set the rules of engagement before the task even begins. Sponsor.
We're back, and we're diving into more complex AI workflows. The advisor pattern is great when the path is mostly clear.
Yeah, it works beautifully for linear tasks with predictable roadblocks.
But what if the task is a massive, complex, unwieldy beast? What if it needs breaking down completely from the very start?
Then you absolutely need to deploy the Orchestrator framework. This is the second major architectural pattern Anthropic officially recommends.
It's designed specifically for massive, multifaceted engineering and research projects. How does this pattern shift the dynamic between the models?
Fable 5 completely flips from being the consultant to being the boss.
Yeah.
It takes charge of the entire operation up front before execution begins.
It acts a lot like an overpaid project manager, honestly.
Pretty much. It delegates all the hard labor and takes credit at the end.
So it becomes the high-level project manager for the entire system.
Yes. Fable 5 plans the whole massive task out initially. It breaks a giant beast into smaller, highly manageable subtasks.
And then what?
Then it assigns them to multiple Sonnet 5 worker agents.
Let's make sure we define these worker agents very clearly. They're smaller AI programs focused entirely on finishing one specific task.
Right. They act like an automated, highly focused digital assembly line. And here's the absolute crucial technical nuance to this entire setup.
Lay it on me.
Each Sonnet worker gets its own completely isolated context window.
Let's unpack the mechanics of that specific design choice. Why is isolating the context window so important for these workers?
It prevents the models from getting confused by irrelevant data. Language models can suffer from a phenomenon called prompt drift.
That's when an AI loses focus given too much irrelevant information.
Exactly. Isolating context allows them to run their subtasks simultaneously without distraction. They don't get confused by each other's specialized, complex data.
They just focus entirely on their one assigned piece of the puzzle. So they're working in parallel, maximizing both speed and accuracy.
Exactly. Whoa. I mean, imagine scaling this specific concept up indefinitely.
It's wild to think about.
You can have millions of concurrent agents operating simultaneously on servers. It's like building a massive, automated digital metropolis from scratch.
Yeah.
The sheer scalability of this architectural concept is completely mind-blowing.
It really is a profound architectural concept to think about. It mirrors how massive human corporations are structured for peak efficiency.
Definitely.
But eventually, all those separate pieces need to come together. What happens when the individual workers finally finish their isolated tasks?
Fable 5 steps back in to review everything they've produced. It carefully looks at all the disparate outputs from the workers.
Looking for errors.
Right. It intelligently resolves any conflicts between the different overlapping pieces. Then it seamlessly merges everything into one final, cohesive answer.
This structure seems absolutely ideal for multi-step data automation pipelines.
It's totally perfect for deep, complex academic research pipelines, too. You can have agents scanning different databases simultaneously for information.
Do we have hard benchmark data for this specific orchestrator pattern?
We absolutely do. Anthropic cites the BrowseComp benchmark for this framework.
And that's a rigorous test evaluating an AI's ability to navigate web tasks.
Correct. Fable 5, leading a team of Sonnet 5 workers, is incredibly effective. It hits about 96% of Fable's solo performance score.
96%.
Yeah, and it does this at around 46% of the total cost.
Getting 46% of the cost is simply staggering. You're getting top-tier reasoning results for less than half the price.
It mathematically proves that intelligent delegation is vastly more efficient. You don't need the smartest brain doing every single microtask.
But isolating the context for the Sonnet workers introduces a risk.
How so?
Doesn't it create a disjointed blind men and the elephant problem during the execution? How do we guarantee all the final pieces actually fit together?
Fable 5's ultimate review phase specifically exists to resolve those exact integration conflicts.
Right. Fable's final review specifically resolves those messy integration conflicts.
Yes, the final review prevents any disjointed outputs from shipping. It acts as the ultimate quality control mechanism for the project.
We have the high-level theory and the benchmark data now. Let's make this highly practical for the listener's actual daily workflow.
Let's do it.
How do we apply this directly in our own software projects? We're talking specifically about using Claude Code directly here.
We should probably define what we mean by Claude Code for the audience.
It's a command line tool for writing and editing code automatically.
Right. And the biggest mistake developers make is pasting tasks blindly into it. You cannot just throw a vague prompt at the entire system.
You need a highly structured, deliberate approach to your prompting.
You must clearly define the ultimate task and the surrounding context first. Tell the system exactly what you want to achieve overall.
Okay.
Then, explicitly assign Sonnet 5 as the primary execution model.
And explicitly assign Fable 5 as the consultant or project manager.
Right. You literally tell it Fable handles architecture, research, or complex debugging.
Let's walk through a very specific real-world example from Anthropic's text.
This is where the abstract theory finally becomes concrete reality. In this specific example, Sonnet 5 starts the entire workflow process.
So it's taking the lead initially?
Yeah, it reads the necessary project files smoothly and completely autonomously. It runs the required terminal commands to set up the environment.
Makes sense.
Then it checks the application dashboard using a tool called Playwright.
Playwright is just a standard tool for automating web browser testing.
Exactly. It's a very common, highly repetitive software engineering chore. Sonnet cleans up the messy project files next, formatting everything properly.
Okay.
Finally, it prepares the initial code commit for the repository.
That's a massive amount of routine, heavily automated execution work.
It is. But then we hit the crucial mandatory final review step. In the example, Fable 5 steps in at the very end.
It reviews the aggregated work before anything ships to production.
And it actually catches a remarkably sneaky time zone bug in the code.
Oh, time zone bugs are notoriously difficult to spot manually during code reviews.
They really are.
They cause massive cascading headaches in live production environments. A time zone bug might pass local tests but fail on global servers.
Yeah.
They require a deep, abstract understanding of how different systems interact.
And Fable 5 catches it purely through its deep reasoning capabilities. It spots the edge case and flags the issue for the execution model.
So Sonnet then goes right back into the code base to address it.
Exactly. It fixes the specific bug based entirely on Fable's architectural advice. Finally, Sonnet verifies the new fix is working properly across the board.
It creates a perfectly enclosed, highly efficient, automated system. But setting up this complex tag team strategy sounds incredibly daunting.
You think so?
Yeah. Does this require complex, custom Python coding to properly set up?
Not at all. It's literally just plain text instructions guiding the model's behaviors.
Got it. It's just plain text instructions guiding the model's behavior.
That's the sheer beauty of this entire cost-saving approach.
Yeah.
You're just managing them like you would manage two human employees.
Let's zoom out and recap the big idea of this deep dive. Claude Fable 5 is an incredibly powerful, deeply capable reasoning tool.
It really is.
But using it for every single step of a project is wildly wasteful. It's a massive, unnecessary drain on your financial compute resources.
The real secret to software efficiency is highly targeted AI reasoning. You have to be incredibly strategic about deployment and resource allocation.
It's like stacking Lego blocks of data in the most optimal sequence. You place Fable 5 only at the most critical structural junctions.
Right.
It handles the high-level planning, the active steering, and the final reviewing. You only use it when a bad decision is fundamentally expensive to fix.
And everything else gets pushed down to the highly capable Sonnet 5. It's all about maximizing your overall return on compute investment.
You get the genius-level insights without paying the genius-level hourly rate. We really want to encourage you to take some concrete action today. Sit down and audit your own AI workflows this afternoon.
Look closely for areas where you're lazily overusing expensive reasoning models.
Try swapping out just one routine execution step in your pipeline. Hand it over to a Sonnet model instead of defaulting to Fable.
Watch the API cost savings materialize in real time on your dashboard.
It will fundamentally change how you approach building modern software.
Your project budget and your wallet will definitely thank you later. Once you see the math work out, you'll never go back.
Pete, I want to leave you with a much broader philosophical thought. We've spent this entire time discussing the absolute mathematical peak of efficiency.
We have.
We're deliberately separating the deep reasoners from the routine executors. This orchestrator model works absolutely flawlessly for artificial intelligence systems.
It's perfect for AI.
But what does this structural shift mean for actual human organizations? Think deeply about your own workplace or corporate structure for a moment.
That's a fascinating angle.
Are we structuring our human teams wildly inefficiently right now? Are we constantly making our most expensive, experienced reasoners do routine execution work?
Probably.
Perhaps the machines are finally teaching us how to properly manage ourselves. Out to your own music.